All right, so today we'll look at section 7.5, which is on sum and difference identities. And to kind of get into the section, I just want to start by kind of thinking about what's on the left versus what's on the right. Before we investigate it or look at that at all, does anybody have any thoughts about how these two things would compare? So you think they'd be the same. So he's kind of thinking you can do distributive property with the word sine. So you might think one comes out like positive and one comes out negative. Okay. Any other thoughts? What's going to happen here? What else could happen besides the possibilities that have been said? They're what? I think someone said they're the same. Yep. What else could happen? Well, John?
Mr. Hager, is this kind of like when you combine logs? Say when you can, like one log plus another log and you can multiply or whatever? Okay,
well, we're going to see what happens. We'll see what the rule is. But what else? If they're not the same, then they could be different. So let's graph them. Okay? Let's put sine of x plus 3. I'm going to put that in y1. And let's put sine of x plus sine of 3. Okay. Before I even hit graph, what kind of transformation is that when you add a number inside the parentheses? Which way does that shift it? It's going to shift to the left 3. How about when you add a number onto the end? Sine of 3 is just a number. It's like 0.05 or something. So what happens when you add a number onto the end of a function? It goes up. That's a vertical shift. So just by thinking about it in terms of transformations, that's a horizontal, that's a vertical. They're not going to be the same. So let's hit zoom 7. Okay, there's sine of x plus 3. Okay, shifted 3 radians to the left. And there's sine of x plus 3 radians shifted, sine of 3 radians shifted up. You can see just barely, I don't know, it's hard to see, but the red one has been shifted up just a little higher than the blue one. Okay? They're not at the same heights. So the idea here is the distributive property doesn't work. Okay, you can't distribute the word sine and get what we have from the left into what's on the right. All right, but there is a formula you can use to figure out what that is. Okay, and there's 4 formulas we're going to look at. We're going to look at sine of a sum. Okay, that's this one. We'll look at sine of a difference. And then we'll look at cosine of the same thing. Cosine of a sum and cosine of a difference. All 4 formulas are kind of similar. That's why I suggest writing them down. So I'm actually not going to start out with the sine one. I'm going to start out with the cosine one. And this is the cosine of a difference. Okay, alpha and beta would be 2 angles. Okay, you could pick any 2 numbers. And if you want the cosine of alpha minus beta, this is what it comes out to. Cosine alpha cosine beta plus sine alpha sine beta. Okay, and at first you might be like, well, why would you take something like this and rewrite it like that? And I'll show you in a second why we do that. The proof of this is on page 409. It's a bit lengthy, and it's not really worth taking 10 or 15 minutes to do it. So, but once you know this formula, okay, you can figure out all the other formulas based on using this one. I think it's easier once you know them if you just memorize them or write them down. It does take a little bit of time if you have to use this one every time to figure out the other ones. So hopefully just make a list of them and then you'll have them all. Okay. Right. So I want to find the cosine of 15 degrees, and I want it exact. Okay? So I can do it like this, but that's a decimal.
Can I have another page of push
This page?
Yes.
Right, so the cosine of 15 degrees is about 0.9659. Okay, but I want it as an exact answer. Can anybody think how I could somehow use the formula on the left to figure out the exact answer of cosine of 15 degrees? And I'll give you a hint. It starts by picking something for alpha and something for beta. And you have to pick something for alpha and beta that's easy to work with. Okay? And think about when we did unit circle trig, the kind of angles that are easy to work with. Yeah?
Would that be like 0 or whatever plus 15 or minus 15 or 15 minus 0?
Well, do we know how to work with angles that are multiples of 15, like off the top of our head?
Yeah.
No, but what angles do we know how to work with, or we should have memorized?
90.
Would-
Those 45, 60 ones.
All right, so multiples of 45, and what other number? Multiples of 30. So if you pick angles that are multiples of 30 and 45, those are easy to work with. So that's another,
So 45 minus 30.
yes. Instead of thinking of it as cosine 15, think of it as cosine 45 minus 30, which is 15. Now you just picked something for alpha and something for beta, and the two things you picked are very easy to work with. Their answers we should have memorized. So now fill in 45 for alpha and 30 for beta, okay, in this formula on the right. So it's going to be cosine, what's going to go here? Cosine 45 times cosine of 30, and then plus
Sine of 45 and sine of 30.
sine 45, sine 30. Right, so we've got all those four terms, and every one of these comes out to an answer we should know. So if you're not sure off the top of your head, you can type it in, but then you have to recognize the decimal. Okay, so the first one is cosine 45. What is that as an exact answer?
Square root of 2 over 2.
That's the square root of 2 over 2. Yep. Times. Now let's look up cosine 30. All right, so cosine of 30, what's that as an exact answer?
Square root of 3 over 2.
That's the square root of 3 over 2. Again, if you don't know these, you can go back and do unit circle trig. But if you have to do 4 unit circle trig problems, this is going to like take 15, 20 minutes just to do this one thing. So it's just easier to have those numbers memorized. All right, sine of 45. Actually, let's use this calculator. Okay, what's the sine of 45? Square root of 2 over 2 times the sine of 30. That one's going to come out nice. 1/2. So now just simplify that calculation, and that's the answer. Okay. Multiply the first two, and then multiply the second two. What do you get when you multiply the first two fractions together? Oh, Curtis?
You get square root of 2, square root of 6
Yep.
over 2, I mean 4.
Over 4? Yep. So square root of 6 over 4.
That reduces the square root of 3 over 2, right?
No, you can't reduce the 6 and the 4 because the 6 is under the root.
Oh,
If the root wasn't there, you could write 3 over 2. Yeah. And how about the second one?
Square root of 2 over 4.
Square root of 2 over 4. Now the last thing is to add those together, but when you add fractions, what do you need to have? We already do. We already have a common denominator, so just put it all together. No, you can't add square roots. You can't. That's all you can do. If you had like square root of 6 plus square root of 6, if you had two roots that are the same, you could write that as 2 square root 6. Like x plus x is 2x. But you can't do anything with that. Okay, so let's check and see our answer if it works. So that's the cosine of 15. Let's see if that comes out to the same thing, 0.9659. Okay, take the square root of 6 plus the square root of 2 and divide by 4, 0.9659. Okay, so by using that formula, you can figure out any angle that's a multiple of 15 by writing it in terms of 45s and 30s. Right, and sometimes there's more than one way to do it. To write 15, you could, can anybody think of a different way you could do 15? 65 minus 40. So you have to pick angles that are multiples of 30 and 45. I agree that 65 minus 40 is 15, but 65 is not a multiple of 30. But you're close. Think of another way you can get an answer of 15 using 45s and multiples of 30. Yeah?
60 minus 45.
Yes. If you wrote this as cosine 60 minus 45, he picked two angles that are multiples of 30 or 45, and he did subtraction, so we could use this formula, and you'd get exactly the same answer. It doesn't matter which way you do it. There's tons of ways you can do it. You just have to pick angles that are multiples of 30 and 45. Right. Let's try this one. So this is a verify, and it says that the cosine of pi over 2 minus theta, somehow that turns into just sine. Well, look at what I did in the last problem. Is what I have on the left here similar to what I did in the last problem? Ian, what do you think?
Yes.
Yeah, it's the same exact thing. It's cosine of something minus something. So why don't we take what's on the left and do that formula again, okay, and see what happens. So this is alpha. This is beta. Right, so when I rewrite what's on the left-hand side, use the previous problem if you need to remember the formula, or if you have it in your notes, you could just look back. What's the first thing I would write? Yep, cosine pi over 2. Okay, so now we're in radians. Keep that in mind if you use your calculator. So cosine pi over 2 times cosine theta. Okay, and what sign comes next, a plus or a minus? Plus. So it's not too hard to remember now, but once we add the other formulas, it's kind of tricky to remember. But when you have cosine and a minus, you use a plus. Okay, that's what's in the formula. So plus, and what are going to be my last two terms? Sine pi over 2. Sine theta. All right, so let's type that in and see what we get. Before I type it in, what do I want to make sure of before I do anything? Make sure I'm in radians. Okay, I already am. Let's do cosine pi over 2. What did I get for that?
0.
Yeah. So I have 0 times something. So what's going to happen to that first term?
Zero.
Yeah, it's gone. Okay, so that part disappeared. Anybody have a guess what the sine of pi over 2 is going to come out to? Yeah, it's going to come out to 1. And now you just have 1 times sine, which is what? Yeah, the sine of theta. And what did the problem say we were supposed to get? Sine theta. So we verified that the cosine of pi over 2 minus theta is the same as sine theta. Yeah.
Why does it, what is zero? Like,
Well-
why does it cancel out with here?
Why is the cosine of pi over 2 0?
Yeah, and then, and the cosine theta, you always cancel the whole thing.
So to figure out why the cosine of pi over 2 is theta, that goes back to drawing our diagram. This is 0. This is 90. That's the coordinate for 90. Well, that's the point. What would the coordinate be for that?
0, 1.
Well, we know it's 0 something. Okay, we don't know how high we
Oh, I
went.
thought we were doing a unit circle.
But yeah, okay, we could do it on a unit circle. Doesn't really matter. So if you're doing it on a unit circle, the coordinate is 0, 1. And what's the definition of cosine? It's which letter in that coordinate? Cosine is the x. Well, it better be, right? Because we at 0. So the x value is 0. That's why the cosine of 90 is 0, because it's the x value of that coordinate.
Yeah, but like the whole,
And that just cancels out this part. Just that.
alright, well, yeah, I get how it cancels out, but isn't this cosine theta too, it cancels that out too?
Yeah, because 0 times anything
Oh, okay.
is 0. Doesn't matter what you have there. Yeah. Any other questions on why the sine of 90 is 1? Well, we already have it. Sine is the y value of the coordinate. Here's the coordinate for 90. The y value is a 1. That's why sine of pi over 2 is 1. If you have to, you can go back and draw the diagram and figure out your coordinates if you need to. But you can use a calculator. That's fine too. All right, let's try this one. It says this time to verify that the cosine of pi minus theta is the same as negative cosine theta. Okay, does this formula fit the pattern that we've been doing? What's on the left?
Cosine alpha is pi, and cosine beta is a theta.
So you're saying it does fit the pattern?
Yeah.
Yeah, it's cosine of a difference. Okay? Eventually, we're going to get into cosine of a sum or something like that. But yeah, this is the same pattern, cosine of a difference. So it's cosine of pi times cosine of
Theta.
theta. Is it a plus or a minus?
Negative.
Yep, plus. And last two terms?
Sine of pi and
Sine of pi, sine of theta. Right, let's see if we can figure out cosine of pi just by making a diagram. Where's pi? How many degrees is that? 180. What's the coordinate right there? Negative 1, 0. And cosine is which letter?
cosine is x, so it's be 0.
I agree cosine is x.
Cosine is a negative 1, sorry.
Yeah. And the x value in that coordinate is negative 1. So we got that. And now the sine of pi, same coordinate. Sine is which letter?
Y.
The y?
Zero.
And the y value of the coordinate for pi, you can see it right there, is a 0. So now you have 0 times sine. What's 0 times the sine of theta? 0. 0 times anything cancels that out. And what's -1 times cosine? Negative cosine theta, which is exactly what we were supposed to get. So on a test, what I'd be looking for something like this is the first step would be to write this out with the 4 terms. And then I'd look, did you simplify the 2 terms that you could? Usually it's like 1s and 0s. And then from there, just write your final answer. Okay? So that's all the work you'd have to show to get credit for that. Any questions on that? All right. So we've got the cosine difference formula. Now we're going to take a look at the cosine sum formula. And it's actually very easy to figure out this formula if you already know the difference one. The difference one is not easy to figure out from scratch. It takes a while. But using that one, we can get this one. Okay, now there are 2 things I have to remind you of when we do this formula. First of all, if you take the cosine of a negative angle, the negative doesn't really matter. Okay, I think we've looked at that before. So if you had the cosine of -20 degrees, it's exactly the same as the cosine of positive 20 degrees. There's no difference. Now, when you have a negative with sine, you can't just get rid of the negative, but does anybody remember where you can move the negative?
To the outside.
You can move it to the outside. All right, so for example, the sine of -10 is the same as the negative sine of 10. Okay, so with cosine, you can get rid of the negative. With sine, you can move it to the front.
Hager, how come is cosine of -x is equals cosine of x and not negative cosine of x?
Because it cancels out. This is a rule from, I don't remember, I think we did it back in chapter 6.
Oh, okay, so negative.
Yeah, if you take the cosine of a negative angle, you can just get rid of the negative. It doesn't make a difference.
Your word for it.
Yeah, take my word for it. All right. So let's see if we can, those 2 rules are going to come up in figuring out the cosine sum formula. That's why I had to remind you of them. All right, so can anybody think how I can write a sum in terms of a difference? Okay, you do this with basic arithmetic all the time. Okay, because I have a formula for a difference. Okay, I just want to think of something I can write here that would be equivalent to this. We want it as a difference because we know the cosine difference formula.
Where's Ryan's?
All right. So can anybody think what you could write here that would be equivalent to what's on the left?
Would it be sine of alpha minus sine of beta? Or
Would it just be alpha minus theta?
Okay, alpha. And then what?
Minus beta. Or minus beta.
Minus beta. Okay. Does everyone see how those are equivalent?
Oh, yeah, I can use the negative minus two to cancel each other out. Great.
Yeah. So we've just rewritten an addition as a subtraction. And if we go back to the other page, we have a formula to do this. This is what we plug in for the first thing. This is what you plug in for the second thing. So let's use the formula we already have, and that'll give us the cosine sum formula. Okay, so how would I break this down using the formula we just looked at? would be cosine alpha. Okay, and then the next thing,
Cosine negative beta.
cosine negative beta. We'll come back to that in a second. And then is it a plus or a minus? It's a plus. Okay. Denver?
I have a question. Why is it when it goes cosine down, why is it cosine negative? Like this, I don't know, it just.
Yeah, why can't you put alpha as a negative instead of beta as a negative? Can you do that?
So how would you want to write it?
Cosine negative alpha. I don't know why, because it looks like it should be a zero cosine.
And then what else would you put?
I just put the other one into it. I don't really know how it works.
So you're basically trying to take something like this and write it as subtraction. The reason we want to write addition as subtraction is because we already have a formula to deal with subtraction. So however you can rewrite this as subtraction is fine. But the only way that I can think to do it would be to do it like that. Subtracting a negative would turn it into a positive. And then once we do this, we're going to have a formula down here in a second. So we're not going to have to do this again. We're just going to have a new formula, and we just want to memorize the formula for cosine of a sum. Okay? But I'm deriving it based on the formula we already have, which, again, we're not going to have to do that in the future. All right, so we have cosine of the first times cosine of the second, and then plus, and what would be my next term?
Sine alpha.
Sine of the first, and can somebody else give me my last term? Well, Brad, can you give me my last term?
Sine of negative.
Yeah, sine of negative beta. So the cosine difference formula is cosine first, cosine second, plus sine first, sine second. That's how you do it. Okay. Now, in this first thing, is there anything there that I mentioned earlier that we could simplify?
You can simplify cosine of negative beta just to cosine of beta.
Yeah, cosine alpha stays the same, but cosine negative beta, you can just write that as cosine beta. The negative doesn't make a difference. All right, how about in the second one? Is there anything there that I can simplify?
Sine of negative beta.
Can we just get rid of the negative?
No, you put it into the sine. So that'd be negative sine equals beta.
You can get rid of the cosine negatives without the sine.
So, right, you can't get rid of this negative, but what can you do with
On
it?
the outside of
You
it.
put it on the outside. Okay, put it all the way in front on the outside. So what's going to happen is that plus turns into a minus. And that's really the only difference between the two formulas, between the difference of a cosine of a sum and a difference.
Is the sign change?
Nope, the only thing that changes is a plus to a minus. I put an extra parenthesis, that's fine. Right, so when you're doing cosine of a sum, the formula uses a difference. When you're doing cosine of a difference, the formula uses a sum. Okay, if you're making a reference sheet, it's not really something you have to memorize, just something you have to look up correctly when you use it. So, any thought what this formula would allow me to do? I mean, I could use it to figure out like sine of 15, but we have an easier way to do that. But this will allow me to figure out something else. I think I could figure out what angle do you think I could do something with now, besides a 15?
Like over 90 or whatever, like that.
Okay, the other formula, we can also do things over 90.
Or negative.
A 45? 45 we already know. Anything that's a 45 we should already have memorized, and a 30. But think about combining those two together. What do you get if you combine those together? A 75. So we can now figure out cosine 75. Okay? Maybe you can figure out a subtraction. You probably could. You could figure out two things you could subtract to get 75. And you could do it the other way. But when I think 75 in my head, the easiest thing I can think of is two numbers that add to give me 75. What are the two angles we can add that are easy to work with?
30 and
We can add 30, and it doesn't matter the order you do it in, and 45. So what? That's the cosine of a sum. So let's split that up using our formula we just came up with. First thing, when you have a sum, what sign does the formula involve? A sum or a difference?
And some.
No, cosine of a sum
Oh,
involves the difference.
yes.
All right, in the final formula you put subtraction. All right. What are the first two terms I multiplied together?
30, 45.
All right, so 30 times 45?
Yes. Or,
Just 30 times 45?
no, it'd be 30 times negative 45, right?
Just like this?
Be a negative. Yes. Oh, cosine.
Yeah, we're going to have all the cosines and sines in there.
Hager, it's 211.
That's all right, you'll get it. So cosine 30. And what's the next one?
times cosine 45.
Cosine 45.
Minus sine 30 times cosine times sine of 45.
Yeah. Okay, so cosine of a sum. Cosine of the first, cosine of the second, minus sine first, sine second. That's the pattern. Now we just simplify it just like we did with 15 degrees. Okay, let's start with cosine 30. Okay, what's that as an exact answer?
Square root of 3.
Yeah. 3 over 2. Okay, does anybody remember the cosine of 45? Square root 2 over 2. This is very fast if you have these memorized. Sine of 30? Yeah, that's 1/2. And sine of 45? Yes. If you don't know those, that's where it's gonna start to slow you down a little bit. Multiply these together. Square root 6 over 4. Multiply those together. These are all the same numbers we just worked with. Square root 2 over 4. And in order to subtract them, I need to have and I already do. That usually happens a lot. We have a 4. And there's your answer.
The exact opposite of the other one.
Yeah, the only difference is it's a plus instead of a minus, or other way around, yeah. Okay, so you could check it on your calculator if you want. Type cosine 75. Type that in, and you'll get exactly the same thing. Now, can anybody think of how you could write cosine 75? Let's say you didn't remember the sum formula, but you remember the difference. Is there a way you can write 75 as a difference of two numbers? And it has to be a 30 and a 45. Ian?
30 minus negative 45.
Okay, so you could think of it as 30 minus a negative 45. Can anybody think of how to do it with two positives, like something minus something? Yeah?
90 minus 15.
I'd like to work with multiples that are 30 and 45. That does work, but it's just not a multiple of 30.
120 minus 45.
Yeah, 120. That's a multiple of 30 minus 45. And if you check it, 120 minus 45 is 75. So you could do this exact same problem as a difference if you didn't want to do it as a sum. Okay? So it kind of gives you some options. If you can't think of one way to do it, maybe you can think of another way. And you will get exactly the same answer. Okay? But that's how I did it because we were practicing a sum. Okay, and the last two are basically when you have sign. So we have sign of a sum, sign of a difference. And now once I learn these, this is where it kind of confuses me and it's hard to keep straight. Is it a plus or a minus? Well, one big thing that's different with the sign of a sum is the formula uses a sum. Sign of a difference, formula uses a difference. That's not how the cosine formula worked. It was the opposite. All right, so it's a small detail, but important to make sure you keep straight. And notice how the sines and cosines are combined. It's not like the cosines are together first and then the sines are together second. They're mixed. It's sine of the first, cosine of the second, cosine of the first, sine of the second. So now it's kind of hard to remember which one goes where. But if you just use your reference sheet, just follow the formula. That's all you have to do. Okay, anybody have a guess the only thing that's going to change when you do sign of a difference? Yeah, the only thing that happens is the formula changes to a minus. Everything else is the same. So if you wanted, you could condense that into one formula, but I think for teaching it to you, it's clearer if I separate it into two. So sign of a difference. Sine first, cosine second, minus cosine of the first, sine of the second. And you can do all the same things with this that we did with cosine. You could figure out sine of 15, sine 75. It's just a way to figure out sine instead of cosine. Any questions on that one? These formulas aren't too bad to figure out if you know the cosine ones from scratch. But we figured out one of them, so I'm happy with that. I don't think we need to figure out these. Just trust me that they are true. Or look them up yourself and you'll see they're true. Does everyone have the formulas? Even if we were doing a test in class this week, I would still let you use a reference sheet. So these are generally not things I have people memorize, because it starts to get kind of a lot to memorize. Now, we're going to look at the same thing for tangent. We don't use tangent as much. We use the sine and cosine ones a lot. But can anybody think how you could figure out tangent? Like if I asked you this question right now, as an exact answer. Yeah, find the sine and the cosine. And what do you do with sine and cosine to get tangent? Exactly. You take the sine and you would divide by the cosine. So here's a way to avoid what I'm about to show you. I'm going to show you a formula to figure out the tangent directly. But if you didn't want to use the formula, and you know how to find the sine, and you know how to find the cosine, you could find each one separate and then divide them. It's more work than just using the shortcut I'm about to show you, but you could do it that way. So any questions on that idea? All right. But there is a shortcut. There is a tangent sum formula, and it's kind of complicated, so we don't really do a lot with it. So in fact, if you're focusing on something for the test, I would focus mostly on the sine and cosine formulas. But just to kind of round everything out and finish up the formulas, I will give you the last two for the sum and difference. These I think are a little harder to figure out. Off the top of my head, I don't remember the proof for figuring out these. And honestly, if I got really stuck and had to figure out a tangent, I would probably just do the sine divided by the cosine. Because these are definitely not formulas that I have memorized. But if somebody gives me the formula and asks me to plug in, that's easy. I can plug numbers in and figure it out. I just need someone to give me the formula, because it's a lot to remember. And again, don't worry as much about the tangent. I would focus more on sine and cosine.
We're not really going to use these on the test.
Yeah, we don't really use these ones much.
This could be like a bonus question.
I think in the past I did a bonus question with them. Yeah. And at most, you might have like one homework question that has tangent in it. But mostly sine and cosine. Okay. Does everybody have the tangent? Okay. So the kind of things you can do with this formula, you could figure out tangent 15, tangent 75, all the same things you can do with the sine and cosine ones. That's it. Okay. Okay. Anybody's got those? All right. All right, so last thing I'm going to look at, kind of the same idea that we started out with. The difference between putting a 2 in front of the x and putting a 2 in front of the whole thing. Just from transformations, I hope people can see these aren't the same. This is a horizontal stretch or compression. How about putting a 2 in front? That's a vertical stretch or compression. So these aren't the same transformations, and they're not the same. The sine of double an angle is actually equal to what I have on the right. And I want to verify that that's true. If you want to take the sine of double an angle, you could do it like that. Now, the reason why a lot of times we rewrite a formula like this is because we don't like to have numbers in front of theta. We like to just get rid of them. But you can't just get rid of it. But this formula gets rid of the 2 in front of the theta. It does make it a little more complicated. But now there's just a 1 here and a 1 there. Right, so can anybody think of a different way that I can write what's on the left? Using something we've learned. I don't want to write it as 2 theta. I want to write it using one of the well, we learned 6 formulas, but one of the first 4 that we learned. Think about 2 theta. How would you get 2 theta as an answer to a problem? What would be the arithmetic involved? Besides 2 times theta. I want a different way to get 2 theta. Just one sign. You're only going to have a sign in the front, but think about the argument part. Or like, let's say you had 2x as an answer to a problem. What's that? Yeah, think of it as theta plus theta. Now look what we have on the left. We have sine of a sum. Let's go back and look up the formula for sine of a sum. Let's use the formula on this, and let's see if we somehow get what's on the right-hand side. So can somebody remind me, what is the formula for sine of a sum? Can you say like sine first, sine second, or cosine second, so I know which one is which?
Sine alpha.
Is alpha the first?
Yeah.
Okay, so sine of that's the first, and that's taking the place of what the second one is. So sine of the first, okay?
Cosine of the first.
Cosine of the first, right?
Sine of the second.
Right, sine of the second, which happens to be the same, so you're not going to notice a difference here, sine of the second,
Cosine of the second.
and cosine of the second. So I have sine cosine plus sine cosine. So I have this sine cosine how many times? Twice. I have 2 sine cosine. And that's where this comes from. And you could double check. You could graph what's on the left in y1, graph what's on the right in y2, and you'd see that they are the same. So in other words, if I wanted to do, let's say, something like the sine of, I'm just trying to think of something, 60. It should be an answer that you know. But you can think of 60 as 2 times 30. 2 times something. So now, if you couldn't figure out the sine 60 for some reason, but you know how to work with 30, you could rewrite it using this, where 30 would be taking the place of theta. So it would be 2 sine 30 cosine 30. If you could figure that out, that would be the sine of 60. We generally don't do that a lot, but you could do something like that, but we don't do as much arithmetic with these. Okay, and that's called a double angle identity. So double angle means that there's a double or 2 in front of the angle. So the whole goal with a double angle identity is to take having a 2 in front of the angle and rewrite it so that there's no 2 in front of the angle. Okay? It's just an angle by itself. And for sine, that's the only way to do it. It's a very, very common way. For cosine, there's 3 different ways to do it. We don't go through the proofs of where these different formulas come from, but I'll show you what they are. So one way to get rid of a 2 in front of an angle with a cosine is to do cosine squared theta minus sine squared theta. Kind of looks similar to a Pythagorean identity, but that's not. What the Pythagorean identity that I'm thinking of, what's different in that identity compared to what's on the board here? This is subtraction. What's the Pythagorean identity? It's addition, yeah. So it's similar, but it's different. But using that Pythagorean identity, sine squared plus cosine squared equals 1, you can somehow use that to figure out this one, which I didn't make you do, I'm just giving it to you, and this one. Okay, so there's 3 different ways you can take cosine of double an angle and rewrite it so that it's just an angle by itself in the argument. When you're doing a problem, if you're not sure which one of these 3 to use, it's kind of hard for me to give you like a general rule, like always use the first one. It depends on the problem. Like if the problem said to rewrite in terms of sine only, well then I would say use the second one. If it said rewrite in terms of cosine, I would use the third one. So it depends on the directions. Okay, and the last one is for tangent of a double angle. Again, the tangent one, you could kind of put an asterisk next to it because it's not one we use a lot. But since I gave you the one for sine and the one for cosine, just to kind of round it out, I'll give you the one for tangent. And I think that's the last formula for today. Okay, so we'll practice using these, but I think I'm just going to do an example that uses the first 2. not the third one. Okay, so what are all these identities called again? These are double angle. Yep. All right, so in the last problem, all I want to do here is take and rewrite what I have using sine and cosine. I don't want to have a 2 next to the x. Okay, so let's look at the first term. Is there a 2 next to the x in the first term? No. This already is in terms of cosine. There's a 2 in front. I don't care about that. I just don't want, I only want there to be 1s in front of the x's. Okay, so the first term can stay the same. How about the second term? Is there a 2 in front of the x there? Yes. Then I need to rewrite this so it's just in terms of sine and cosine. So how can I rewrite sine 2x?
2 sin theta times cosine.
Yeah, this time we're just using x's instead of thetas. 2 sine x, cosine x. This is the same as that because of what's on the previous page. Now, what's the number, oops. What's the number that's in front of the x's in both those terms? 1. So now I've written everything with a 1. Now, if they asked me to factor this, what do both terms have in common? A cosine x? Even more. A 2. So they could ask me to factor out anything that's in common. They didn't on this one. But just in case they do, I want to show you how that works. If you factor out a 2 cosine x from the first term, what are you left with inside here? A 1. And if you factor a 2 and a cosine x out of the second term, what are you left with there? A sine x. And that's all you could do. If they don't ask you to factor, you can stop here. If they do, stop there. Okay, so now there's no more 2's in front of the x's. Okay, so any questions on that? Okay, so I think we learned like 9 or so different formulas. The sine sum and difference, cosine sum and difference, tangent sum and difference, and then you had the double angle, 3 double angle formulas. And actually one of them had multiple versions. So I would just keep those on your reference sheet. And that's really the last big set of identities we work with. So you've got the Pythagorean ones, the quotient ones, the reciprocal ones, and now you've got the double angle and the sum and difference. Okay, and that pretty much is all we do with them in pre-calc. Okay, and if you're wondering in general, is that all the identities there are? No, there's thousands. There's thousands of different identities. You guys know about 20 or so? But you know the most common ones. All right, so the homework tonight, it's on 417. Okay, and it kind of skips around a little bit, so it's 2 through 5, 9 and 10, 17, 18, 29. On number 31, only do part A. I think there's a part B, but you don't have to do that. And then 37 and 41. Okay, so we'll take a look at that tomorrow, and then tomorrow we will finish up chapter 7.